Welcome back. It's now time for us to cover the topic of reproducibility. If I could even spell it, that would be fantastic. Reproducibility. Trying to take the random out of random. So we've touched upon the concept of neural networks harnessing the power of randomness. And what I mean by that is we haven't actually built our own neural network yet, but we will be doing that. And we've created tensors full of random values. And so, in short, how a neural network learns is start with random numbers, perform tensor operations, update random numbers to try and make them better representations of the data. Again. However, if you're trying to do reproducible experiments, sometimes you don't want so much randomness. And what I mean by this is if we were creating random tensors, from what we've seen so far is that every time we create a random tensor, let's create one here, torch.rand, and we'll create it of 3, 3. Every time we run this cell, it gives us new numbers. So 7, 7, 5, 2. There we go, rand again, right? So we get a whole bunch of random numbers here every single time. But what if you were trying to share this notebook with a friend? So say you went up share and you clicked the share link and you sent that to someone and you're like, hey, try out this machine learning experiment I did. And you wanted a little less randomness because neural networks start with random numbers. How might you do that? Well, let's just write down to reduce the randomness in neural networks and PyTorch comes the concept of a random seed. So we're going to see this in action, but essentially, let's write this down. Essentially, what the random seed does is flavor the randomness. So because of how computers work, they're actually not true randomness. And actually there's arguments against this, and it's quite a big debate in the computer science topic, whatnot, but I am not a computer scientist, I am a machine learning engineer. So computers are fundamentally deterministic. It means they run the same steps over and over again. So what the randomness we're doing here is referred to as pseudo-randomness or generated randomness. And the random seed, which is what you see a lot in machine learning experiments, flavors that randomness. So let's see it in practice. And at the end of this video, I'll give you 2 resources that I'd recommend to learn a little bit more about the concept of pseudo-randomness and reproducibility in PyTorch. Let's start by importing Torch so you could start this notebook right from here. Create 2 random tensors. We'll just call this random tensor A equals torch.rand, and we'll go 3, 4, and we'll go random tensor B equals torch.rand, same size, 3, 4. And then if we have a look at, let's go print random tensor A, print random tensor B, and then let's print to see if they're equal anywhere. Random tensor A equals random tensor B. Now what do you think this is going to do? If we have a look at 1 equals 1, what does it return? True. So this is a comparison operator to compare 2 different tensors. We're creating 2 random tensors here. We're going to have a look at them. We'd expect them to be full of random values. Do you think any of the values in each of these random tensors is going to be equal to each other? Well, there is a chance that they are, but it's highly unlikely. I'll be quite surprised if they are. Oh, again, my connection might be a little bit... Oh, there we go. Beautiful. So we have tensor A, tensor of 3, 4, with random numbers, and we have tensor B of 3, 4 with random numbers. So if I was to share this notebook with my friend or my colleague or even you, if you ran this cell, you are going to get random numbers as well. And you have every chance of replicating one of these numbers, but again, it's highly unlikely. So again, I'm getting that automatic save failed. You might get that if your internet connection is dropping out. Maybe that's something going on with my internet connection. But again, as we've seen, usually this resolves itself if you try a few times or just keep coding. If it really doesn't resolve itself, you can go File, is there Download Notebook? Or save a copy in Drive, Download. You can download the notebook, save it to your local machine, re-upload it, so upload notebook and start again in another Google Colab instance. But there we go, it fixed itself. Wonderful. Troubleshooting on the fly. So the way we make these reproducible is through the concept of a random seed. So let's have a look at that. Let's make some random but reproducible tensors. So import torch, and we're going to set the random seed by going torch.manual seed random. Oh, we don't have random set yet. I'm going to set my random seed. You set the random seed to some numerical value. 42 is a common one. You might see 0, you might see 1, 2, 3, 4. Essentially, you can set it to whatever you want, and each of these you can think of 77, 100 as different flavors of randomness. So I like to use 42 because it's the answer to the universe. And then we go random seed. And now let's create some random tensors. Random tensor C with the flavor of our random seed. 3, 4, and then we're going to go torch tensor D equals torch.rand 3, 4. Now let's see what happens. We'll print out random tensor C, and we'll print out random tensor D, and then we'll print out to see if they're equal anywhere. Random tensor C equals random tensor D. So let's find out what happens. What gives? Well, we got randomness. We set the random seed. We're telling PyTorch, hey, flavor our randomness with 42. Torch manual seed. Let's try set the manual seed each time we call a random method. And we go there. Much better. So now we've got some flavored randomness. So a thing to keep in mind is that if you want to use the torch manual seed, generally it only works for one block of code if you're using a notebook. So that's just something to keep in mind. If you're creating random tensors one after the other using assignment like this, you should use torch.manual seed every time you want to call the rand method or some sort of randomness. However, if we're using other torch processes, usually what you might see is torch manual seed is set right at the start of a cell, and then a whole bunch of code is done down here. But because we're calling subsequent methods here, we have to reset the random seed. Otherwise, if we don't do this, we comment this line, it's going to flavor the randomness of torch random tensor C with torch manual seed, but then random tensor D is just going to have no flavor. It's not going to use a random seed. So we reset it there. Wonderful. So I wonder, does this have a seed method? Let's go torch.rand. Does this have seed? Sometimes they have a seed method. Seed, no it doesn't. Okay, that's all right. The more you learn, but there's the documentation for torch.rand. And I said that I was going to link at the end of this video. So the manual seed is a way to, or the random seed, but in Torch it's called a manual seed, is a way to flavor the randomness. So these numbers, as you see, are still quite random, but the random seed just makes them reproducible. So if I was to share this with you, if you were to run this block of code, ideally, you're going to get the same numerical output here. So with that being said, I'd like to refer to you to the PyTorch Reproducibility document, because we've only quite scratched the surface of this, of reproducibility. We've covered one of the main ones, but this is a great document on how to go through reproducibility in PyTorch. So this is your extra curriculum for this. Even if you don't understand what's going on in a lot of the code here, just be aware of reproducibility because it's an important topic in machine learning and deep learning. So I'll put this here. Extra resources for reproducibility. as we go PyTorch randomness. We'll change this into Markdown. And then finally, the concept of a random seed is Wikipedia random seed. So random seed's quite a universal concept, not just for PyTorch. There's a random seed in NumPy as well. So if you'd like to see what this means, yeah, initialize a pseudo-random number generator. So that's a big word, pseudo-random number generator. But if you'd like to learn about more random number generation computing and what a random seed does, I'd refer to you to check out this documentation here. Woo! Far out. We have covered a lot, but there's a couple more topics you should really be aware of to finish off the PyTorch fundamentals. You got this. I'll see you in the next video.